Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 19 from the Smith Organic Chemistry textbook. And this problem asks us to look at three alkenes and draw the products that would be formed if we treated each alkene with ozone and then worked up the reactions with zinc and water. And so remember, these conditions are going to do what we call an oxidative cleavage. And so essentially we're going to cut through these alkene double bonds and then replace the double bond with carbonyl groups. So one way to think about doing this would be to just draw a red line through each of these double bonds and then redraw these molecules with carbonyls instead. And so for A, that's going to look like this. So this is the carbon that was formerly part of the double bond. And so instead of having a double bond to another carbon, it's now going to have a double bond to oxygen. So that's going to be acetone that we made there. And then we can do the exact same thing with the other piece, the piece from the other side. So this is now going to be an aldehyde. CH2, CH3. Okay, and so there are our two pieces for A. And so B and C are going to be exactly the same. We're just going to draw this molecule, draw each of the pieces around the double bond that we cut, and then instead of having the double bond, just have carbonyl groups. So for B, our first piece is going to look like this. So then rather than have the double bond, we can just put an oxygen there. So we're going to have that aldehyde, and then, and I forgot a plus sign there. Okay, so let's add that. So we'll have this aldehyde, and then we'll have the other aldehyde. So that's going to look like this. Okay, and so that's B. C is a little bit different because it's a ring. It's a double bond in a ring. And so even though we are ozonalizing that double bond, this molecule is still going to be held together by, the connections on the other side of the ring. And so that's fine. We just need to, and you know what? I'm actually going to draw this a little larger because that'll be easier. So we still are going to make two carbonyl compounds. We just need to recognize that they're going to be, on the same molecule, since this was a ring. And so that's going to look like that. So it's just a dicarbonyl. And so, again, that's the way I think to approach this type of problem. Just draw a line through the double bond that we're cutting, and then draw the parts of the molecule to either side. And remember to just replace that double bond with carbonyls. And that's the answer to Chapter 12, problem number 19.